Okay, so today is 10th problems 7 class. So chapter 5, 1, 13. Okay, so for 13, have an angle of degrees, 17 side length. I'd like to find, it says, find the remaining sides and angle. Okay, so we have triangle, sides is alpha, the opposite side is A, one of the angles beta, the opposite angles. Come on. So we need to find B, gamma, and I think the easiest one to find is going to be gamma because we know that the angles have to add up 180 minus 13 minus 17 gives us B. Gamma should have been. Diagram doesn't matter except for being able to organize the 180 minus 13. 7, 17. Yes. Okay. We found gamma. Now we have all the angles and we have one of the sides, so we can use the sine, the law of sines, find sides. Sine of 13 degrees over alpha. Wait, over 5 sine of 17. Don't know. Solve this. I'm going to take the reciprocal of both sides over sine of 17. 5 over sine of 13. And then I'm going to multiply both sides of the equation by sine 17 degrees. That gives me the side that I'm looking for, equal 5 sine of 17, 13, which I can calculate 2. This does do. So I want to take B degrees right now. So I'm going to take 17 degrees. I'm going to take the sine of that, and that 927. Note of that. Again, 923. Copy. Okay, then I clear everything. I'm going to do 13 degrees. I'm going to reciprocal. This is now 1 over sine of 13 degrees. Multiply this by. I multiply this by This gives me an approximation of, depending on where we want to round, either 6.5 or 6.49. But anyway, we now know what B is. Found gamma. Gamma is one. Have 17. Here we haven't figured. This side is 5 because it was given to us. This was whatever our calculator. 6.498. And now we have to find this side. We do the same. So 5 degrees over reciprocal of both sides over sine of 50 degrees equals 5 over sine degrees. Multiply both sides by equals 5 over sine. So we want the sine of 13 like before. 13 invert already 4.2. So going to need sine of 150. The reason that I'm doing the sine of 150 first is that it's going to be easier to multiply by whatever that value is as I plug it into because of the calculator. It's going to be easiest to plug in 13, take the sine, take the reciprocal, then multiply by 5, and then multiply by sine of 150. So I need to know what the sine of 150 is first to be able to do 50 sine 5. Should have known special angles take. But if I don't, then I can use my calculator. And then I want 13 degrees. I want to take the sine of that, reciprocal of that, then multiply by 5, multiply by sine 5. I get 11.113. That is C. This triangle is now solved. Based on the textbook. The textbook said to find the 3 angles and the 3 sides. Sometimes classes in certain books, finding the area as part of solving it. But that wasn't in the instructions in this text. So we're not going to find the area. Let's see. The next one is set of 2 angles and a side. So you find the third angle by subtracting from 80 plus sine. 17 have This one has an angle 2 sides, so let's try doing that one. This one have triangle 17. Have one angle is 117. Yes, that would be bigger than 90 if the triangle were drawn to scale. And then we have the opposite angle 35. Sorry, the opposite side is 35. And we have another side that is 40. Side B, one opposite is beta. Side C, the opposite of that would be. So we need to find beta, gamma, and C. Let's see. We can find beta using the law of sine. We have sine of alpha over A, beta B. Oh, this is going to be. Uh, huh. This is obviously, because it's more than 90, it's obviously. So it should be opposite the biggest side. This is bigger than. Get an error. So you get sine of B, sine of beta equals 42 sine of 17. Plug this in the calculator. Plug in 117. Sine of that. Multiplied by. I get that's beta. That's bad because sine is never bigger than 1, but 1.06 is bigger. So this is an error. It doesn't exist. No touch. Which is what I had expected, as this angle should be the biggest angle, and this is not the biggest side. 17. Okay. Number 19, we have an angle. We have two sides. I'll try. Opposite that is a side of 88 degrees. Side B, 2 degrees. We're side C, gamma, and beta. We have the tools necessary to find beta. Sine of beta over B equals sine of alpha over, so sine of beta, 90 sine of 8. Get our calculator. Seven sine of that multiplied by 2 divided by 80 gives us this number, where we're going to do arc sine 76.9. We do have to round a little. Rounding is not terribly. Okay, so beta is that. So now we have that this is beta, this alpha. If I add these things together, subtract that from 1. have this number here. Let's add 68 34.3. So that is what angle 180 alpha beta 34.3. And then now that we have gamma, we can use that to find C using sine of gamma 8 degrees over C equals sine of, we'd want to use A and alpha because there's no rounding there. Exact value. So 7 degrees. Solving for C gives us C. Flip it over top, bottom, sine up. Okay, have that. Get our calculator. We're going to need to know the sine of 34.8. That's 0.5647. Clear everything. 7. Sine of that. Reciprocal. Multiplied by 8. Multiplied by 567. Get 53. Side. One of the two angles I was missing. Their angle. You know, 2. Gamma was 38. Both of those. So we've done an example with two angles and a side. We've done an example with an angle and two sides that turned out not to exist. Another one where we had an angle and two sides and it did exist. Let's So one thing I do want to talk about is there's something called an ambiguous case. So the ambiguous case comes from, let's say I know this side A, or well, this okay, labeling side B, this side A, this angle alpha. Well, there's nothing that's prohibiting me from just that information from having AB over here. So if I have an angle alpha, that just tells me what the directions of these two sides have to be relative. And I know B is this amount here. And I know A is this distance here, but it's possible that A could be pointing this way. This side and this side could be the same length, but A might either lean out or lean in, making a triangle, the base either this size, that size. We have to be able to tell, well, when does that happen? When do we have an ambiguous case? So one way to tell, because sometimes if I'm creating a triangle, I get a right triangle, and if I know B alpha, I don't get to. There's only the one case because I'm not able to do this lean. They're lean outward triangle. Triangle. This one. But if I have a vertical A, I can't swap between leaning out or leaning in because there is no appropriate. So if this angle is 90, then we're only going to have one solution in the ambiguous case where we know angle, it's opposite. But if this angle is not 90, then we can take this side here and we can just make an isosceles triangle where this side and this side are the same, and this angle are the same, and we get two different versions of the triangle. So going back up to here, we found one triangle where all of these angles are acute. They're all less than 9, where beta is 76. What could have happened? What if we had this angle 76? Which would make this angle 180 minus 76, 103.08. And that would change well. And this angle was given to us. This would stay the same. So this angle would stay the same. Seven. Oh. So it's 67 degrees. If we add these together, we get 178. And that means that this angle at 103.08, 7. Two of the angles. The third one has to make it add up to 180, so the point. And then we could use the law of sines to find the missing sides. We knew A and B, but we could find C, and then we have all three angles. So for the alternative triangle here, we have alpha 8.7 degrees, beta is degrees, gamma 2 degrees, A and B are the same were 35 and 42. C comes, well, we have to use sine of 35 equals sine of 2 degrees over so C equals 35 times the sine of degrees. Calculator. Type in 8.22 degrees. With that, get 0.14297. That rounds to 143. Mark later. Now I plot again. 8, 7, sine this. I take reciprocal, I'd get that. 5 times 3, get 5.37. This is the alternative triangle. This is the triangle we get if we take the and this way. Triangle we got previous is we take the pieces. This is called the ambiguous case. There are the time that happens is when you are looking at a triangle, given information about a triangle, and you have an angle and the opposite side and one other side. If the angle that goes with the unpaired side that you're given, so if in this case beta is less than 90 degrees, then you have to check. You know this angle, you're given this side and this side. You have two sides and an angle that is not the angle between them. Okay? If you have that configuration, then if you get a sine, if you use your law of sines to get an angle that is less than 90 here, then you also get a triangle like this potentially, where this is the angle that comes out of the law of sines, and this is the complement of that angle. Now, that doesn't happen if you get this angle being 90 or bigger. Okay, so that's one thing. If angle beta is equal to 90 degrees, or if beta is over 90 degrees, well, then you did something strange because the law of sines can't do that. The law of sines can't give you a beta greater than 90. That's why the law of sines defaults to give you this, even when this is possible. Both of these are possible solutions. If you're asked to solve a triangle that's ambiguous, you have to give both solutions. This can't happen because the law of sines doesn't output values bigger than 90 degrees. But if you get beta equals 90 degrees, then you have one solution done. If you get beta less than 90 degrees, then you have to consider two cases. Okay? And what can happen is with less than 90 degrees, with this arrangement, you're going to be fine. This is alpha, this is beta. You subtract both of those from 80, you get gamma. You do this triangle, and you're fine. With this one, you get two possibilities. One is that you know your alpha and you know your alternative beta, the complement of whatever you got out of the law of sines, so something bigger than 90. You subtract and you get another angle up here, and that's gamma, and you go just like before. Or the other option is that when you try and add alpha and beta together, you get above 180 degrees, and that tells you that this triangle is not possible. There's only, and it's the one that you get from law of sines. Okay, so there's kind of this flow chart you have to go through where you do the law of sines. Like if you have side, side, angle, side, side, angle. If you have a side angle set of information, then you use the law of sines to find the missing angle. Now you have two angles and two sines. There are two angles and two sides because you use the law of sines to get missing angle. Then you say, well, did I get that angle is 90? If I did, I'm done. I have one triangle and I finish solving that one triangle. If I get less than 90, I have to take those two angles and see, I subtract them from 180. So this is alpha, this is beta. I subtract them from 80, I find gamma. Then try complement of what I got from the law of sine. And subtract that from 180. And if that gives me a positive angle for gamma, then I have two different triangles. I have to solve both of them. Okay. If I get something negative up here, then I don't have. Okay. Lots of triangle solving. It says 13 odd. Anything that has two angles in it, you subtract those from 180 to get the third angle, then you just pull off sines to find the missing. 31 is like that, 29 is like that. 27 has one angle and two sides. We draw out the triangle. We're told beta. Yes, we beta 102. And we're told B is 5. C, we've been using this side for. So with this, we have a side, and an angle. And the angle is not between the two sides. So this is a potentially ambiguous case. Let's walk through 102 degrees. Okay, so from here, this is potentially going to be ambiguous, meaning that we might have two possible values for side A, and we might have two possible angles. Okay, so this. Okay, so we're going to use the law of sines. Sine of. So we know beta, and we have angle C gamma. Let's try and find sine of gamma over 13 equals sine of 102 degrees. Oh, this can't be ambiguous because this angle is over 90. If that angle is over 90, that means that we're not going to get another angle that's over 90. I said there are two possible values for alpha in this equation. That would be true if the angle we knew was smaller than 90. Once you have one angle bigger than 90, you can't have two angles bigger than 90. So this is not going to be ambiguous. We're only having one triangle here. Okay, so we have sine gamma over 13, sine 102 over 16.75. Multiply both sides by 13. Sine of gamma, 13 times the sine of 02 degrees, 5. Get my calculator out. 102 sine that is that divided by 0.75 is this. Now we take the arc sine of that. So we get 43.39 degrees. Okay. And that means that beta is you have alpha is the other angle we know. That's going to be 180 minus the 102 minus 43.9. And 180 minus 102 is 72. 72 minus 43 is going to be 29.8. Yeah, 20. Okay, so those are our angles. Alpha is 21 degrees. Beta is given to us at 1 degrees. Gamma 43. Know that A, way to do that is sines. So A over sine degrees. We want to use B. Those are the values we. So we have 16.75 over sine of 1 degrees. Take this and I save that for later. 0.478. Then 2 sine of that. I inverse of that by that 5.47. This gives me A equals 8. There is my solved triangle. Okay. Those are what homework like today. It's just on homework. 5 point. Five point two. So this we have A is 7, 12, gamma. That's a gamma, but this is like an up. Their gamma. Okay, we have gamma is 59 point. Need to find alpha, beta. So we're going to use the law of cosines for this. We have c squared equals plus squared minus cosine of gamma. So we just plug this in. Squared equals 7 squared is 49. 12 squared is 4. Subtract 2 times 7 times 12. So 7 times 12 is 4 times 2 gives us 49. Later. 3 cosine at negative add get. This isn't what I want. I want the square root of square root. N if I 1. I'm going to round that to 6. C is square root. And now that I know that, well, I know an angle and its opposite side, so I can use the law of sines to get the other one. Sine of 9.3 degrees 6 equals sine of 12 beta. Beta equals 10. Oh, I'm sine of beta over 12. Okay, so we get beta sine 12 sine of degrees over 10 point. Calculator. We're going to type 3 sine of that 12 divide by this sine. This gives me 4.5. Similar thing for alpha. Sine of A was 7. Alpha over 7. Solving this, alpha 9 of 7 degrees over 6. Seven, 6, 35. Now, here's the problem, though. If I add these up, I'm not going to get one. Those are too small. Have plus 35, 2, 5, not even close to 1. What went wrong? Well, it's that ambiguous case again. So we were given this information. We were given this information. Got well, actually, this might not be. Might be the case that sine doesn't or angles bigger than. So let's take a look. When we look at our sides, we have the smallest side is the biggest side is B, and the middle side size is. So what should happen is the smallest angle should be alpha. Smallest angle is always opposite the smallest side. That looks okay. And then since angle C is the middle-sized side, it goes 7 is the smallest, 10.3 the middle, 12 is the biggest. And so what's happening here is we have the smallest side goes to the smallest angle. That's good. The middle side should go with the middle angle. Side goes with the middle angle. But the big side should go with the biggest angle. Like that, those are in order. But what's probably happened? Let's see. We were given this information. Arc sine does not invert to bigger than 90. So it's possible that gives us the when the angle of the triangle is bigger than 90 and you try and use arc sine to find it, it gives you the reference angle. Reference angles are less than 90 degrees. They're always in quadrant 1. So if your angle is supposed to be like 135, if that's the angle of your triangle, arc sine will tell you 45 because that's the reference. So what's going on here is we were given the reference angle for one of our angles. And it's likely beta was B was the biggest side. This angle could be bigger. Look at our angle sum again. 9.3 gamma plus 5. That's plus 35.5. Oh wait, no, that's close to 1. That you before. Oh, I think I added these as this is a side, not an angle. This is the angle. I needed to add this angle with. Okay, and that does come out to be 180. Up to rounding. There's a little bit of rounding here, but yeah, that looks good actually. Okay, so this is a correct solution. The angles add up to 180. If we had a defect, then what we do is we have to identify which of these sides needs to be, which of these angles. These are the angles. This one was a given angle, so it's not an option. But one of the calculated angles, the ones that we found using the law of sines, might be a reference angle, not an actual. Okay? That didn't happen here. I'm going to upload another video. I'm going to find an example where we have the law of sines giving us a reference angle, and I will show you what that looks like. It didn't happen here, but I need to show you what it looks like for cases that does happen. All the time I have to right now. I will soon. I will try and upload sometime in the next few days a video specifically about arc sine giving you a reference angle instead of the actual. Having a day. Send me any questions you have on the homework. I test this weekend, so luck on that.